All right, welcome back to another exciting algebra episode. Today we're going to talk about equations with rational numbers. We use equations to represent real life situations, and sometimes in real life, numbers can be messy. We're not always going to get whole numbers and integers. So a lot of times the problems can involve fractions and decimals, and we need to be able to handle those as well. Go ahead and pause and add this to your table of contents. Start a new entry, and we're going to look at solving equations with decimals and fractions, which are rational numbers. All right, so here's an example. A dog food container is 1/3 full. After adding a 10-pound bag, the container is 3/5 full. How much can the container hold when it's full? How can we write an equation to represent this situation? So we want to know how much the dog food container holds, so that's our x, and so we would work everything around that. So it has 1/3 x right there, 1/3 of the way full, plus 10 pounds equals 3/5 of the way full, and x is our dog food container. But oh man, it's got fractions in it, and they have different denominators. Super annoying. What a pain in the butt. So I'd start by moving my smallest pile of x's. So my smallest pile of x's would be 1/3 x, because it's less than half, so I know it's smaller than 3/5 x, which is more than half. And then I'm left with 10 equals whatever this is. So I need to go 3/5 minus 1/3, and they're different denominators, so I need a common denominator. So I would multiply by 3. On that one, I'd multiply by 5 on that one, and I'd end up with 4/15. So I have 10 equals 4/15 x, and then I have to multiply both sides by the reciprocal, which is 15/4. So now that cancels out, and I'm left with x over here like I wanted. If I multiply across by that, I get 150/4. I can also cross cancel, and then I can divide, and 150 divided by 4 is going to be 3750 or 37.5. All right, well, that was a lot. Wouldn't it be great if there was a shortcut to that problem? Wouldn't it be great if I could get rid of the fractions entirely? There is a way.
Not all multi-step equations look the same. Let's take a look at some and see how we could use different techniques to solve different types of equations. Check it out. 2y/5 plus 3/5 equals -1/5. How in the world are we going to solve that? Well, I'm going to show you right now, because what you want to do is notice that what is it that you don't like about this particular equation? It's all those fractions. Oh no, fractions. They make life a little bit difficult sometimes. So it would be great if we could just get rid of the fractions. Now we can. If we can figure out the least common denominator, which in this case is easy, it's all 5, so we know the least common denominator, the LCD, is 5. Then we can multiply both sides of the equation through carefully by 5, and that should clear out all the denominators. Let's see that in action. So first I'm just going to write down the equation as is. So I'm just copying this down. Nothing special. But now I'm going to multiply both sides by the least common denominator of 5, 5, and 5, which is just 5. So this side I multiply by 5, and this side I multiply by 5. Notice I'm putting parentheses around everything, because in this case I have to make sure that 5 multiplies not only this term but also multiplies this term. Namely, I've got to distribute that 5 across to here and also way over to here. So you have to remember that. So putting parentheses helps me remember that. Anyway, let's now multiply through. When I multiply through by 5, I see that I can simplify the 5 in the numerator and the 5 in the denominator, and I'm just left with 2y plus, and then again here I see 5 factor in the numerator, a 5 factor in the denominator.
All right, to summarize what Professor Berger was talking about, first we're going to find, he called it the lowest common denominator. We really just need to find the lowest common multiple or least common multiple of all the fractions in the problem. Then we're going to multiply by the lowest common multiple by all the terms on both sides, and then we're going to solve it. Go ahead and pause and copy that down. So if I go out to this original problem here, I can say, okay, what's my common multiple between 3 and 5? So, if I count by 3s and I count by 5s, what do I get to first? And hopefully you can come up with 15. So now I did my first step. And now my second step is to multiply the LCM by all the terms on both sides. And the biggest mistake people make is they only multiply by the fractions. But, you got to multiply by all the terms. So slap some giant parentheses on there, put a 15 on both sides, go ahead and bump it. There you go. All right, so I can cross cancel here. I can just multiply across and divide. So if I go 15 times 1, 15 divided by 3 is 5. So now I got 5x. 15 times 10 is 150. And then over here, if I go 15 times 3, I get 45 divided by 5, and that gives me 9x. And now I have a problem with no stinking fractions in it. And then I can just solve like we talked about in the last lesson. Move my smallest pile of x's. That gives me 150 equals 4x. And then I divide by 4 on both sides, and I end up with x equals 37.5. Bam. All right, let's do a couple for our notebook. So nice, we're going to write it twice because we're going to ugly this thing up. So go ahead and write it twice. All right, so now I'm going to look at my denominators here, and I'm going to find the LCM of my denominators. So what's the LCM of 7 and 7? That's easy. It's 7. So now I'm going to do step 2, and I'm going to put giant parentheses on here. I'm going to put a 7 on the outside, and I'm going to bump it to help me remember that I need to multiply by every single term on the inside. All right, so the 7 and 7 cancel out, and I'm left with k. 7 times -6 is -42. Over here, the 7's cancel out, and I'm left with 3k. And 7 times 4 is 28. Now I'm going to minus k from both sides. And that's going to give me, there, I made more room for the problem. So it's going to give me -42 equals 2k plus 28. And then I'm going to try to isolate k, so I'm going to minus 28 from both sides. And then that's going to give me -70 equals 2k. And then finally, I'm going to divide by 2. And then I'm going to say that k equals -35. A check on these kind of problems are honestly a big pain in the butt, so I'd skip it if I were you. All right, here's the second problem. Go ahead and write it twice. Okay, so now I look at all my denominators. I have 10, 2, and 5, and I want to find the lowest common multiple of 10, 2, and 5. So if I count by 2s, 5s, and 10s, what am I going to get to first? And that's 10. You can always start with the biggest number and see if that works. All right, so now I'm going to get my giant parentheses out. Slap 10 on both sides. Bump it. And then I can get to work. All right, the 10 cancels out there, so I'm left with 7n right there. And then if I go 10 times 3 is 30, divided by 2 is 15. 10 times 3 is 30, divided by 5 is 6. So I have 6n there, and 10 times 2 is 20. I'm going to move my smallest pile of n's. And then I'm going to get n plus 15 equals 20. And now I'm just left with the one-step equation. Minus 15 on both sides. And I'm left with n equals 5. There you go. All right. Grab a piece of scratch paper. Go ahead and try this one problem. Work the steps. And that's it. So show up tomorrow with your notes done, any questions that you have, and make sure you try that one problem. Get a good night's sleep, and I'll see you in school tomorrow. Bye.